afternoon, coming to you with a fractional piece equation here. Now, just to be clear on what this symbol means, fractional piece, like some people write it like this, fractional piece of x. You can write it in terms of the floor function if you want to. I didn't choose that route. I think I have a better way here. This is equal to x minus the floor of x. Okay, that's definitional. For example, if you wanted to do let's say the fractional piece of 13 over 6, that would be equal to 13 over 6 minus its floor. And now the floor is just what they call the greatest integer function. So it'll be 13 over 6. So that's 2 and 1/6. You already see the answer is 1/6, but to use the floor function to make it, to realize this, that would be minus 2 right there. Okay, minus 2. So that's equal to 1/6. One over 6. So that's what we mean by the fractional piece. All right. Now, what I did down here, the first thing I did, folks, is we know that the right-hand side of this equation has to be trapped between 0 and 1, just by the nature of the fractional piece. It's a number between 0 and 1. It can't be 1, actually. A number between 0 inclusive, 1 non-inclusive. All right. Anyway, we get these conditions right here. This is just straightforward. If you add 55 over 27 to both sides and take cube roots, you get that x has to be between 1 and 2. Very useful. Okay, so we know that if there's a solution, it has to exist between 1 and 2, and this probably means there is a solution. Now, also, just to reiterate, this piece right here, if you wanted to you see this function right here would still work out the very same way, right? See, 13 over 6. 13 over 6 is certainly contained in the interval of closed 2, open 3. All right, folks, 2, 3, like that. Well, it's not supposed. That's supposed to be a 2, 3 right there. All right, and so you see I is equal to 2, which is exactly the 2 that you see right here. I won't rewrite it, but the floor of x actually is just equal to this minus this, which is very, very connected to this, of course. But it's a way to think of it without thinking of the floor function. Okay. Now, but in any event, what we do now is, since we know that our x is between 1 and 2, this would be our new I right here. See, I. Our x has to be in the interval 1, 2, right? 1, 2. So that'd be 1 here, 1 plus 1, 1, 2. And so that's why we're using x minus 1. So we can actually equate the right-hand side of the equation to the linear function x minus 1. Now, when you do that, this is fairly straightforward. We get a cubic. Oh, no, a cubic, okay? But it's, I guess, what they call a depressed cubic. There's no squared term. Notice that rewriting it like this, we get this cubic, and we can write down the potential rational zeros based on the rational zero theorem. Remember, any rational zero, the numerator has to be a divisor of the constant term, and the denominator has to be a divisor of the leading coefficient. Now, I think there's only 3. No, I think 28 over 27 can be crossed out because, look, it's a smaller number than the cube root of 55 over 27, all right? You can check it if you don't believe it, but it looks like 14 over 9 and 4 over 3 are still in this interval right here, okay? Now, so I checked 14 over 9, it didn't work. So let's check 4 over 3, okay? So we'll do the floor of 4/3 is trivially, not the floor, I keep saying that. The fractional part of 4/3 is equal to 1/3, right? 4/3 is 1 and 1/3, so its fractional part is 1/3. Right? No doubt about that. Now let's check to see. And again, y'all, I tried 14 over 9, and I'm just not going to show that work. It didn't work out. It turns out that 4/3 does work out. And so let's do that. Let's substitute. Let's do, and y'all, I'm just working with this piece right here. Okay, this piece, I mean, I'm just looking, I'm substituting into the right-hand side up here. So what we'll get 4/3 quantity cubed. 4/3 quantity cubed is 64 over 27, right? 4 times 4 times 4 is 64, and 3 times 3 times 3 is 27. So you get 64 over 27. Well, okay, let's just keep writing. Now let's do the minus 55 over 27, right? And y'all, again, hopefully all I'm doing is substituting 4/3 into the right-hand side of our original equation. Okay, so this right here is 64 over 27. 64 over 27 minus 55 over 27. We have a common denominator. We can subtract the numerators because of that. So 55 over 27. So the problem is tantamount to just subtracting 55 from 64. And so that gives us 9 over 27. But guess what? That reduces to 1/3. Isn't that cool? So this is the one time that the function evaluates to its fractional piece, so to speak. Okay, so that's equal to 1/3. Pretty cool, folks. That's the only time. The fractional piece is sometimes called the sawtooth function, and it's always trapped between 0 and 1. The line, this function can take on all negative and all positive values. It has a range from minus infinity to infinity. But in any event, we're done right now because we got 1/3 for the left-hand side, and we got 1/3 for the right-hand side. I thought that was super cool. I may have overlooked some numbers right here, but we know just by the nature of the sawtooth function, it's a linear piecewise. And so you could have multiple intersection points, but unless I left a number out of this list, this is the only solution. The actual answer to the question is x equals 4/3. Okay, so that is final answer right there. X equals 4/3. And this is the justification for why 4/3 is the answer. Hope you enjoyed it.